This is the video for Mod 7, Lesson 7, Radians. The goal of this video is going to be looking at another way to measure angles, which is with radians, and how to evaluate a trig function in radians with our unit circle. So what we're going to see is our first topic is converting to radians, and really what we do is we're relating radians to the circumference of a circle. And so a unit of measure that's used for an angle that's related to the radius. That's why it's called a radian, and we write it in terms of pi. And essentially, if we think about a circle that has a radius of 1, the circumference is 2 pi r, or 2 pi. So what we are thinking is then we also know an angle is a circle is 360 degrees. So if we know that 2 pi relates to 360, that basically, if I divide by 2, we're basically saying 180 degrees is pi, which is like 1 radian. We call that a radian. And so we can eventually do that so we don't have to constantly think about things in terms of a degree. So you're not going to measure out 180 little tick marks on the x-axis eventually if we want to graph this. So it's really kind of thinking about how can we make things within the same scale. And so it looks tricky, but really what we're doing is we're just converting. So we're going to multiply to go from degrees to radians. We multiply by pi over 180 or convert. And then if we're going from radians to degrees, we're multiplying by 180 over pi. So we're looking for when we're going to degrees, the pi cancels out. And when we're going from degrees to radians, we're going to have a pi in our answer. All right, so for the first question, what we're thinking about is, again, we're saying 180 degrees is equal to 1 radian. Basically, right? So we're converting here. So I'm going to write it kind of like how maybe you would see it in like science class, but same thing, we're just going to convert. So we're seeing, well, 30 degrees, what would that be in radians, right? So if I converted that to be in terms of like a circumference, so we would have 30 degrees. I'm going to write it like this. And we know that for every 180 degrees, there is 1 radian, so 180 over pi. You could also write it as times pi over 180. I'm just using the top one because I know that a lot of people use those in science class already. So if I multiply it, it's really like in your calculator, you're like doing 30 over 180, and we like to leave it as a fraction, right? So we're going to leave pi in our answer. We don't want to put the pi in our calculator, and the part you're going to put in your fraction in your calculator, you can do alpha y equals, or you can make it a decimal and then turn it into a fraction. When we put that in our calculator, we're going to get 1/6. And we're not going to write 1/6 pi. We're actually going to write it as pi over 6. So you're just going to put the pi in your final answer. So 30 degrees is the same as pi over 6 radians. Same idea with 225 degrees. So 225 degrees, and for every 180 degrees, that's 1 radian. And same thing, if I multiply across, or I can cross cancel. And then in my calculator, you're not going to type in the actual pi. We're just putting in the 225 over 180. So you could do alpha y equals in your calculator. You can make it a decimal and then convert it to a fraction. As a fraction, that's 5/4. So we would say 5 pi over 4. And that's how many radians that would be. For the next one, same idea. We're just going the other direction. So again, we're saying pi radians, or 1 radian essentially, is 180 degrees. Right? Because that's what we're looking at here. So if I convert this, I have 3 pi over 4. If I want the pi to cancel, I'm going to put a pi down here. So for every 1 radian, it's 180 degrees, right? And that's the same again if I wrote 3 pi over 4 times 180 over pi. These are the same thing, just whatever you're kind of comfortable using. The pi's cancel out, and really what we're putting in our calculator now is 3/4 times 180, right? So you can multiply across if you like. That would be 540 over 4. Or you can, just put it all in at once, and you would get 135 degrees. For the last one, same idea. So we have 5 pi over 12. 1 radian is 180. I know I'm doing it right because my pi's cancel out. And so when we multiply this across, or you can put this all in your calculator, either one works. And then when we reduce, we would get this to be 75 degrees. All right, now what we want to do is we want to take our unit circle and convert all of the degree measurements to radians, right? Because once we do this, we don't have to do this really ever again. We can just kind of use this as a reference. So anytime they give us a measurement, we can look off our unit circle to get our unit circle tells us our cosine, our sine, and then tangent of theta is y over x. If you did convert those, this is what it would look like. So for 0 degrees, it's 0. You would have had pi over 6 for 30, pi over 4, 45, and so forth. So this is what you probably want to have on your unit circle. So you're able to just look off it as a reference now. In this example, we're basically going to use our unit circle now to answer our question. So remember that points are in the form of cosine comma sine, where tangent is y over x. So we're going to look for where do we see 2 pi over 3, and we can either convert it, we can just find it, we can kind of see where it falls if I make it into a decimal. 2 pi over 3 actually falls, it's at 120. And we're looking for cosecant, which is actually the reciprocal of sine. So that's going to be our y value. So if I find sine, I could just flip my answer and then be done. So 2 pi over 3, sine is going to be root 3 over 2. So if I want cosecant, I have to flip it and then make sure I rationalize it out. And that would be my final answer. So 2 root 3 over 3. Same thing for tangent of 5 pi over 4. I'm going to look to see where do I see 5 pi over 4 in here. So I could either convert it and find it as an angle, as a degree measurement. I can see where it falls. I can memorize it. 5 pi over 4 is actually 225. And for tangent, I have to do y over x. So I'm doing negative root 2 over 2 divided by negative root 2 over 2. A negative over a negative is a positive, and this is a positive 1. So tangent of 5 pi over 4 is 1. If you have questions from the notes, please make sure you're asking questions in class, during T-Bolt time, or in the center. You do need to complete the U-tries to receive full points for these video notes. So when these are checked in class, you do need to make sure you have your U-tries completed to receive full points. So again, the remaining problems from this section need to be completed, even if they're not perfect. We need to see that you're trying the steps out before you come to class so you're ready to ask questions. All right, thank you very much and have a great rest of the day.